Have you ever pondered how many species have vanished from the face of the Earth? The answer might astound you. Welcome back to Random Realm. I'm Jessica. This is a journey through time, where we'll uncover the enigmatic history of mass extinctions. Before we get started, make sure to hit that subscribe button and ring the notification bell so you never miss out on our future explorations of the universe. In the grand tapestry of Earth's history, life has been both a persistent and resilient force. Yet it's also been subject to cataclysmic events that have dramatically altered its course. These events, known as mass extinctions, have punctuated life's narrative with periods of abrupt, brutal endings and gradual, hopeful beginnings. Scientists recognize 5 major mass extinctions in Earth's history, each one a unique chapter in the story of life. The first of these catastrophes occurred about 440 million years ago, during a period known as the Ordovician. It resulted in a staggering loss of 70% of all species. A mere 50 million years later, Earth was struck by the second mass extinction, the late Devonian, which saw a similar loss of life. The third, the Permian-Triassic extinction, was the most severe. It wiped out a mind-boggling 96% of all species. The fourth mass extinction, the Triassic-Jurassic, was less severe but still catastrophic. The fifth and most famous of all, the Cretaceous-Paleogene extinction, ended the reign of the dinosaurs and paved the way for the rise of mammals, including us, humans. But what caused these mass extinctions? Well, the culprits range from volcanic eruptions and climate change to asteroid impacts. And while each event was a catastrophe, they also brought about opportunities for new life forms to evolve and thrive. Mass extinctions are not just relics of the past. They serve as stark reminders of the fragility of life and the profound impacts that environmental changes can have on all living beings. As we delve into each of these extinction events, we'll explore not only what was lost, but also what was gained and what lessons we can learn for the future. So, let's unravel the mysteries of Earth's mass extinctions, one event at a time. Journey with us back to around 443 million years ago, to the first major extinction event. This cataclysm, known as the Ordovician-Silurian extinction event, was a dark chapter in our planet's history. During this period, Earth's climate swung from a greenhouse to an icehouse, resulting in widespread glaciation. The dramatic cooling led to a significant drop in sea levels, drastically altering habitats and causing the demise of many marine species. Indeed, the Ordovician-Silurian extinction event was particularly catastrophic for marine life. Imagine a world where around 85% of all marine species suddenly disappeared. This extinction event primarily affected organisms like brachiopods and bryozoans, while other groups such as mollusks, echinoderms, and trilobites also suffered significant losses. The causes behind this extinction event are still a topic of much debate among scientists. The leading theory suggests a combination of volcanic activity, changes in the planet's orbit, and the invasion of rapid, aggressive species. This event marked the first massive wipeout of life on Earth, but it wouldn't be the last. Fast forward to about 360 million years ago, the Earth faced another catastrophic event. This period is known as the Late Devonian extinction. A time when life on Earth was primarily ocean-dwelling, the Late Devonian extinction saw a massive decline in aquatic biodiversity. This extinction event is thought to have been triggered by a series of unfortunate circumstances. Volcanic activity, sudden climate change, and a drop in sea levels were among the many factors. These adverse conditions resulted in a significant loss of marine habitats, spelling disaster for the creatures that called these places home. The repercussions were severe. Coral reefs were decimated and many species of fish were wiped out. But it wasn't just life in the oceans that suffered. The effects rippled through the entire ecosystem, impacting terrestrial life as well. The Devonian extinction was a slow, drawn-out event, yet it was a grim sign of what was yet to come. Imagine an event so cataclysmic it wiped out almost 96% of all marine species. Picture a time around 252 million years ago, marking the end of the Permian period and the start of the Triassic. This period witnessed the most severe extinction event in Earth's history, known as the Permian-Triassic extinction event, or more ominously, the Great Dying. This extinction event was so devastating that it erased nearly 3/4 of all land species, along with the staggering majority of marine life. So, what could have possibly caused such a massive wipeout? Well, scientists have been piecing together this puzzle for years, and while the complete picture still eludes us, several compelling theories have emerged. One leading theory points to massive volcanic eruptions in what is now Siberia. These eruptions would have spewed enormous amounts of greenhouse gases into the atmosphere, leading to a dramatic rise in global temperatures. This rapid climate change could have caused the oceans to become acidic, depleting oxygen levels and making it impossible for many marine species to survive. Another theory suggests that the extinction may have been caused by a sudden release of methane from the sea floor, a sort of underwater burp of gas, which would have had a similar greenhouse effect, rapidly warming the planet. Regardless of the exact cause, the aftermath of the Great Dying was profound. The Earth's biosphere took millions of years to recover, and when it did, the world was a very different place. Entire ecosystems had been rearranged, new species had evolved, and old ones had disappeared forever. This extinction event also set the stage for a new era of life on Earth, the Mesozoic era known as the Age of Dinosaurs. With so many ecological niches now vacant, the dinosaurs, along with other reptiles, were able to evolve and thrive, dominating the planet for the next 185 million years. The Great Dying, as it's often called, was a turning point in Earth's history, paving the way for the rise of the dinosaurs. Picture a world where dinosaurs no longer roamed. This isn't a hypothetical scenario, it's a historical reality that marked a pivotal moment in our planet's history, the Cretaceous-Paleogene extinction event. As we delve into the mysteries of this event, we're transported back some 66 million years ago to a time when the Earth was a vastly different place. The era was the Late Cretaceous, a period characterized by a warm climate, high sea levels, and an abundance of life, most notably the dinosaurs. Then, in the blink of a geological eye, everything changed. A catastrophic event occurred that reshaped the course of life on Earth forever. The most widely accepted theory attributes this mass extinction to the impact of a large asteroid or comet. The impact site, known as the Chicxulub crater, is located in what is now the Yucatan Peninsula of Mexico. Imagine an asteroid about 9 miles wide hurtling towards Earth at an unimaginable speed. Upon impact, it released energy equivalent to billions of nuclear bombs, causing massive fires, tsunamis, and sending a cloud of dust and debris into the atmosphere. This dust cloud enveloped the planet, blocking out sunlight and leading to a dramatic drop in temperature, a scenario often referred to as nuclear winter. The aftermath of this event was devastating. Plant life struggled to survive in the drastically altered climate, disrupting the food chain from the bottom up. Without their primary food source, herbivorous dinosaurs faced starvation, and the ripple effect continued up the food chain, leaving even the mighty T-Rex in dire straits. The Cretaceous-Paleogene extinction event led to the extinction of approximately 3/4 of the plant and animal species on Earth, including the non-avian dinosaurs. It was a cataclysm that marked the end of an era, closing the book on the Age of Dinosaurs. Yet, as with all endings, it also signified a new beginning. With the dinosaurs out of the picture, other forms of life had the opportunity to flourish. This event marked the end of the reign of dinosaurs and paved the way for mammals to dominate. Now that we've journeyed through Earth's past, what can these mass extinctions teach us about our future? It's a hefty question, isn't it? The history of our planet is marked by these catastrophic events, but they are not merely historical footnotes. They are cautionary tales echoing through the eons, reminding us of the precarious balance of life. Let's think back to the Ordovician-Silurian extinction event. The world was locked in an ice age, and as the glaciers melted, they flooded the oceans with cold water, disrupting marine life. This event whispers a warning about the perils of rapid climate change, a topic we're all too familiar with today. Then, there was the late Devonian extinction. Oxygen levels in the water plummeted, resulting in a deadly environment for marine life. The lesson here? Ecosystems need balance. They thrive within certain parameters, and when those are drastically altered, life struggles to survive. The Permian-Triassic extinction event, often called the Great Dying, was the most severe. A staggering 96% of marine species perished. The cause? Likely a combination of volcanic activity, methane release, and subsequent global warming. This event underscores the devastating impact of greenhouse gases on life. And of course, the Cretaceous-Paleogene extinction event, which wiped out the dinosaurs. It's a stark reminder of the external threats our planet faces from the cosmos. Now, why does all this matter? Because we're currently in the midst of what scientists are calling the sixth mass extinction. Biodiversity is declining at an alarming rate, and climate change is a significant driver of this loss. But unlike past extinctions, this one is largely caused by human activities. So what do? We learn from our planet's past. We strive to understand and respect the delicate balance of ecosystems. We work to mitigate the effects of climate change and protect the rich tapestry of life on our planet. As we stand on the brink of another possible mass extinction, the lessons from the past remind us of the fragility of life on Earth and our role in preserving it. As always, thank you for joining me on Random Realm. Until next time, stay curious and keep exploring the wonders of our world. See you in the next video.
It's London Lee.